Module 4, Inter-VLAN routing. So in this topic, okay, we have 4 topics, subtopic for this module. So objective of this module for troubleshoot inter-VLAN routing on layer 3 devices. Okay, all right. So inter-VLAN routing operation. So what is inter-VLAN routing? VLAN are used to segment switch layer to networks for a variety of reasons. Regardless of the reason, hosts in one VLAN cannot communicate with hosts in another VLAN unless there is a router or layer 3 switch to provide routing services. Inter-VLAN routing is the process for forwarding network traffic from one VLAN to another VLAN. There are 3 inter-VLAN routing. Okay, so first, legacy inter-VLAN routing. Second, a router on a stick. Third, layer 3 switch using switch virtual interface or SVI. Okay. So legacy inter-VLAN routing. The first inter-VLAN routing solution rely on using a router with multiple Ethernet interfaces. Each router interface was connected to a switch port in different VLANs. The router interfaces serve as the default gateway to the local host on the VLAN subnet. Legacy inter-VLAN routing using physical interfaces works, but it has a significant limitation. It is not reasonably scalable because routers have a limited number of physical interfaces, requiring one physical router interface per VLAN quickly exhausts the physical interface capacity of a router. So note, this method of inter-VLAN routing is no longer implemented in switch network and is included for explanation purpose only. Okay, please take note. So router on stick inter-VLAN routing. The router on stick inter-VLAN routing methods overcome the limitation of the legacy inter-VLAN routing method. It only requires one physical Ethernet interface to route traffic between multiple VLAN on a network. A Cisco iOS router Ethernet interface is configured as an 802.1q trunk and connected to a trunk port on a layer 2 switch. Specifically, the router interface is configured using sub-interfaces to identify routable VLAN. So the configured sub-interfaces are software-based virtual interfaces, so that each is associated with a single physical Ethernet interface. Sub-interfaces are configured in software on a router. So each sub-interface is independently configured with an IP address and VLAN assignment. Sub-interfaces are configured for different subnet that correspond to their VLAN assignment. This facilitates logical routing. When VLAN tag traffic enters to router interface, it is forwarded to the VLAN sub-interface. After routing decision is made based on the destination IP network address, the router determines the exit interface for the traffic. If the exit interface is configured as an 8021Q sub-interface, then the data frame VLAN tag with a new VLAN and send back out the physical interface. Note the router on a stick method of inter-VLAN routing does not scale beyond 50 or 50 VLANs. Inter-VLAN routing on layer 3 switch. This modern method of performing inter-VLAN routing is to use a layer 3 switches and the switch virtual interface or SVI. And SVI is a virtual interface that is configured on a layer 3 switch as shown in the figure below. So not a layer 3 switch is also called a multi-layer switch as it operates at layer 2 and also layer 3. However, in this course, we use the term layer 3 switch. Right. So inter-VLAN SVI are created the same way that the management VLAN interface is configured. The SVI is created for a VLAN that exists on the switch. Although virtual, the SVI perform the same function for the VLAN as a router interface would. Specifically, it provides layer 3 processing for packets that are sent to or from all switch ports associated with that VLAN. The following are advantages of layer 3 switches for inter-VLAN routing. They are much faster than a router on stick because everything is hardware switch and routed. There is no need for external links from the switch to the router for routing. They are not limited to one link because layer 2 interchannels can be used as trunk links between the switches to increase bandwidth. Latency is much lower because data does not need to leave the switch in order to be routed to a different network. They more commonly deploy in a campus LAN than routers. The only disadvantage is that layer 3 switches are more expensive. 4.2 router on a stick inter-VLAN routing. Router on a stick scenario. So in the figure, so which figure? This, yeah. The R1, okay, the R1 gigabit Ethernet 001 interface. Okay, the one that you can see, this one, the highlighted, yeah. So is connected to the S1 fast Ethernet 05 port. The S1 interface 01 port is connected to S2 fast internet 01 port. Okay, so these are trunk links. So what are these? These are trunk links that are required to forward traffic within and between VLANs. Okay, so to route between VLANs, the R1 gigabit Ethernet 001 interface is logically divided into 3 sub-interfaces as shown in the table. The table also shows the 3 VLANs that will be configured on the switches. Assume that R1, S2, and S1, S2 have initial basic configuration. Currently, PC1 and PC2 cannot ping each other because they are on separate networks. Only S1 or switch 1 and switch 2 or S2 can ping each other, but they are unreachable. But they are unreachable by PC1 or PC2 because they are also in different networks. To enable devices to ping each other, the switches must be configured with VLAN and trunking. And the router must be configured for inter-VLAN routing. Okay, S1 or switch 1 VLAN and trunking configuration. Complete the following step to configure S1 with VLAN and trunking. Step 1, create and name the VLAN. Step 2, create the management interface. Third, configure access port. Finally, step 4, configure trunking ports. So these are the steps. So S2 VLAN and trunking configuration. The configuration for S2 is similar to S1. So here are the examples you can see in this diagram. R2 sub-interface configuration. The router on stick method requires you to create sub-interface for each VLAN to be routed. A sub-interface is created using the interface sub-interface ID global configuration mode command. The sub-interface syntax is the physical interface followed by a period and a sub-interface number. Although not required, it is customary to match the sub-interface number with the VLAN. So each sub-interface is then configured with the following 2 commands. First, encapsulation.1q, and then this is a VLAN ID. All right, so this is a command we use that. So this command configure the sub-interface to respond 802.1q encapsulated traffic from the specific VLAN ID. So the native keyword option is only appended to the native VLAN to something other than VLAN 1. Next, the command IP address. Okay, IP address, which is you need to type the IP address, including the subnet mask. So this command configures the IPv4 address for the sub interface. This address typically serves as the default gateway process for each VLAN to be routed. So each router sub interface must be assigned an IP address on a unique subnet for routing to occur. When all interfaces have been created, enable the physical interface using the no shutdown interface configuration command. If the sub interface is disabled, all sub interfaces are disabled also. Yeah. So in the configuration, the R1, yeah, GOO1 interfaces, sub interfaces are configured for this VLAN, yeah, VLAN 10, 20, and also 9, 9. Okay, so you can check the command. Okay, all right. So verify connectivity between PC1 and PC2. So the router on stick configuration is complete after the switch trunk and the router sub-interfaces have been configured. The configuration can be verified from the host, router, and switch. From a host, verify connectivity to a host in another VLAN using the ping command. It is a good idea to first verify the current host IP configuration using ipconfig Windows host command. Next, use ping to verify connectivity with PC2 and S1 as shown in the figure. The ping output successfully confirmed inter-VLAN routing is operating. Right? So router on the stick inter-VLAN routing verification. In addition, to use ping between devices, the following show command can be used to verify and troubleshoot the router on a stick configuration. Show command that we're going to use later. Show IP route, show IP interface brief, show interfaces, and show interfaces trunk. So packet tracer, we have some exercises. Configure router on a stick inter-VLAN routing. So in this packet tracer, you will complete the following objective. First, add VLAN to switch. Second, configure sub-interfaces. Finally, part 3, test connectivity with inter-VLAN routing. Okay, you can get this from NetAcad, this packet tracer. So for the lab as well, we got this kind of lab. Okay, we will use this lab also for practicing in our real device lab. Yeah. Next, 4.3 inter-VLAN routing using layer 3 switches. Layer 3 switch inter-VLAN routing. Inter-VLAN routing use the router on stick method is simple to implement for a small to medium-sized organization. However, a large enterprise require a faster, much more scalable method to provide inter-VLAN routing. Enterprise campus LAN using three layered switches to provide inter-VLAN routing. Layer 3 switches use hardware-based switching to achieve higher packet processing rate than routers. Layer 3 switches are also commonly implemented in enterprise distribution layer wiring process. Capabilities of layer 3 switch include the ability to the following tasks. Route from one VLAN to another using multiple switch virtual interfaces, SVI, and convert layer 2 switch port to a layer 3 interface. For example, a routed port. A routed port is similar to physical interface on a Cisco IOS router. To provide inter-VLAN routing, layer 3 switch or layer 3 switches use SVI. SVI are configured using the same interface VLAN, VLAN ID command, this one, to create the management SVI on a layer 2 switch. A layer 3 SVI must be created for each of the routable VLAN. Layer 3 switch scenario. So this explanation based on the right diagram or figure. This referring to this diagram. So in the figure, so here they call figure. So the layer 3 switch D1 is to two hosts on different VLANs. PC1 is in VLAN 10 and PC2 is in VLAN 2. So the layer 3 switch will provide inter-VLAN routing services to the two hosts. Layer 3 switch configuration. Complete the following step to configure S1 with VLAN and trunking. Step 2, create the VLAN. In the example, VLAN 10 and 20 are used. Step 2, create the SVI VLAN interfaces. The IP address configured will serve as a default gateway for hosts in the respective VLAN. Next, step 3, configure access port. Assign the appropriate port to the required VLAN. And step 4, enable IP routing. Issue the IP routing global configuration command to allow traffic to be exchanged between VLAN 10 and 20. So this command must be configured to enable inter-VLAN routing on layer 3 switch for IPv4. So layer 3 switch inter-VLAN routing verification. Inter-VLAN routing use a layer 3 switch is simpler to configure than the router on a stick method. After the configuration is complete, the configuration can be verified by testing connectivity between the hosts. From a host, verify connectivity to a host in another VLAN using ping command. It is a good idea to first verify the current host's IP configuration using ipconfig Windows host command. Next, verify connectivity with PC2 using ping Windows host command. The successful ping output confirms inter-VLAN routing is operating. Routing on layer 3 switch. If VLAN to be reachable by other layer 3 devices, then they must be advertised using static or dynamic routing. To enable routing on a layer 3 switch, a routed port must be configured. A routed port is created on layer 3 switch by disabling the switch port feature on a layer 2 port that is connected to another layer 3 device. Specifically, configuring the no switch port interface configuration command on a layer 2 port, convert it to a layer 3 interface. Then the interface can be configured with IPv4 configuration to connect to a router or another layer 3 switch. A routing scenario on layer 3 switch. In the figure, the previously configured the D1, yeah, D1 here. Layer 3 switch is now connected to R1. And then R1 and D1 are in an open shortest path first OSPF routing protocol domain. Assume inter-VLAN has been successfully implemented on D1. So the G001 interface of R1 has also been configured and enabled. Additionally, R1 is using OSPF to advertise its two networks, which is 10.10.10.0 and also 10.20.20.0. Notes. OSPF routing configuration is covered in another courses, which is in the next in internet working module. Yeah. In this module, OSPF configuration command will be given to you in all activities and also assessment. It is not required that you understand the configuration in order to enable OSPF routing on the layer 3 switch. Routing configuration on layer 3 switch. Complete the following step to configure D1 to route with R1. Step 1, configure the routed port. Use the no switch port command to convert the port to a routed port. Then assign an IP address and subnet mask. Enable that port. Step 2, enable routing. Use ipconfig global configuration command to enable routing. Step 3, configure routing. Use an appropriate routing method. In this example, single area OSPF version 2 is configured. Step 4, verify routing. Use the show IP route command. Finally, step 5, verify connectivity. Use the ping command to verify reachability. So here are the packet tracer exercises in order to understand the concept of a layer 3 switching and also inter-VLAN routing. So you need to configure in this packet tracer. So this packet tracer will complete the following objective. First, configure layer 3 switch. Next, configure inter-VLAN routing. And next, for configure IPv6 inter-VLAN routing. So this packet tracer you can get from our NetAcad website. Yeah. So 4.4 troubleshoot inter-VLAN routing. So common inter-VLAN issues. There are why an inter-VLAN configuration may not work. All are related to connectivity issues. First, check the physical layer to resolve any issues where cable might be connected to the wrong port. If the connections are correct, then use the list in the table for other common reason why inter-VLAN connectivity may fail. Okay, so issue type, for example, we got missing VLAN. Okay, so it's like identify the issue. So maybe VLAN, yeah, is missing. So how to fix? Once you done the fix, you need to verify it. Okay, this is normally we do it, yeah, especially for troubleshooting. All right. So there will be another later on, okay, packet tracer, which including the troubleshooting issues. So first you need to identify, like this example. Okay. So after you identify that what kind of the issue, like this example, and then you need to fix that, and later you need to verify whatever setting. Okay, we need to verify and then shows in the report writing. All right. So for example, missing VLAN. So you need to create or recreate the VLAN if it does not exist and ensure host port is assigned to the correct VLAN. So here are the commands used to verify it. And for the issue like switch trunk port issue, so ensure trunk are configured correctly. And next, ensure port is a trunk port and enable. After that, you have to use this command to verify all this. Next, switch access port issues. Assign correct VLAN to access port. Ensure port is an access port enabled. And finally, host is correctly configured in the wrong subnet. So this is a command to verify it. And next, router configuration issues. So for that, you need to check the router sub-interface IPv4 address is correctly configured. Next, router interface is assigned to the VLAN ID. So this next after that, verify the setting or what we call this fixing issues. Use this command. Yeah. So troubleshoot inter-VLAN routing scenario. Example of some of this inter-VLAN routing problem will now be covered in more detail. This topology will be used for all of these issues. Okay. So router R1, which has sub interfaces like this example. Yeah. And we got 3 sub interfaces. So we have 3 VLAN as well. And also 3 network addresses. So missing VLAN and inter-VLAN connectivity issues could be caused by a missing VLAN. So the VLAN could be missing if it was not created. It was accidentally deleted, or maybe it is not allowed on a trunk link. Okay. When a VLAN is deleted, so any port assigned to the VLAN become inactive. They remain associated with the VLAN and thus inactive until you assign them a new VLAN or recreate the missing VLAN. Recreating the missing VLAN will automatically reassign the host to it. So use this command show interface and also switch port command to verify the VLAN membership of the port. Okay, so this is the detail that if we use this show interface and this port to check. Yeah. Okay, so here is the example. It will display the current VLAN. Yeah. Okay, switch trunk port issue. So another issue for inter-VLAN route includes misconfigured switch port. In a legacy inter-VLAN solution, this could be caused when the connecting router port is not assigned to the correct VLAN. However, with a router on stick solution, the most common cause is configured a trunk port. Verify that, yeah, we need to verify that port connecting to the router is correctly configured as a trunk link using show interface trunk command. And then if that port is missing from the output, examine the configuration of the port with the show running config interface. So which one, the interface command to see how the port is configured. So here are the details on that. Yeah. So switch next for the switch access port issue. So when problem is suspected, the switch access port issue. When a problem is suspected with a switch access port configuration, use verification command to examine the configuration and identify the problem. A common indicator of this issue is the PC having the correct address configuration, which is IP address, subnet, and also default gateway, but being unable to ping its default gateway. So that use the show VLAN brief, show interface X switch port, and show running config interface command to verify the interface VLAN assignment. All right. So router configuration issues. Router on stick configuration problem are usually related to sub-interface misconfiguration. So that verify the sub-interface status using the show IP interface brief. Then verify which VLAN each of the sub-interfaces is on. To do so, the show interfaces command is useful, but it generates a great deal of additional unrequired output. The command output can be reduced using iOS command filters. In this example, use the include keyword to identify that only lines containing the letters GI, G, or 802.1Q. Okay, so this is some filtering that you can use in iOS command. So we got another packet tracer exercises. So these packet tracer exercises for troubleshooting. So in this packet trace activity, you will complete the following objective. First, locate new network problem, identify that, implement, and verify. Okay, as I told you, that table. So that table, you have to, in my exercise of my packet tracer, so you have to generate the report, writing, especially identify the problem, solution, what's the solution, and also verify or verify to double check whether is this that configure has been configured properly. So we need to verify that. So 3 things we will do in this activity and also in my activity later on. Right. So we got also another packet tracer for troubleshooting. This one in physical mode, let troubleshooting the routing. So this is also another activities. Okay. So 4.5 module practice and quiz. So this is you can go through all this, packet tracer activity, configure, all this VLAN routing, and later on to troubleshoot. So you can through all this question as well. Yeah. All right. That's regarding chapter 4. Right. See you later. Thank you.